question 1 stated a chemical compound with the molecular formula of C9H10O2 exhibits the following spectral data. So in this question, the information of UV, carbon-13 NMR, mass spec, and also 1H NMR are given.
So for the UV test, the maximum absorption wavelength of the carbonyl group we can find is around 268. So the wavelength we get is a 264 and also a 262. So it is in the range of carbonyl group lah. So the second maximum absorption wavelength we found of the number 257 nanometers and also 255 nanometers is at the range about 255. So it indicates the presence of the benzene ring. So this one is for the UV test. So for the FTIR test, we can find that with the different number, it got a different bond and different functional group. So uh, as it's more simple and more easier wavelength we can find is the 3440. So this one is the functional group, is the alcohol group with the OH stretch. So and solar about 3060, 11730. So the 1220 with the aromatic functional group and also ester saturated aliphatic with the different bond with the C double bond O, C single bond H, C single bond C. So this one is for the FTR test.
For the 1H NMR, the chemical shift is 2.1 ppm with the multiplicity of single and integral factor of 3H. So this means that the NMR peak has only a single peak and it has 3 hydrogen, so it assigns a CH3 isolated. So for the chemical shift of 5.10 ppm, the multiplicity is single and the integral factor is 2H. This represents that the NMR peak is single and it has 2H, so it assigns a CH2 isolated. For the chemical shift of 7.35 with the multiplicity of single and integral factor of 5H. So this means that the NMR peak is singular with 5 hydrogen. So this is assigned an aromatic isolated. Whereas for the 13C NMR, the chemical shift is 170 ppm, which represents a functional group of carbonyl. It might be ester, amide, or carboxylic acid. For the chemical shift of 128.1 until 136.2, the functional group could be a substituted benzene. And then for the chemical shift of 66.1, the functional group could be an alcohol or an ester. Lastly, for the chemical shift of 20.7 ppm, the functional group could be an aromatic.
Based on the table they have provided and knowing that the molecular formula of the compound is C9H10O2, we know that the molecular weight of the entire compound is 150 gram per mole. As you can see, the molecular weight of carbon is 12 and we have 9 carbons. The molecular weight of oxygen is 16 and we have 2 oxygen, and the molecular weight of the hydrogen is 1 where we have 10 of it. Thus multiplying and adding together would result in 150 gram per mole. Referring to the table with the 4 peak given, we were able to identify this following ion where C double bond O bonded with CH3 have MZ value of 43. Next is benzene bonded with CH3 have MZ value of 91. Benzene bonded with CH2 bonded with O have MZ value of 108. And lastly, and the overall it will have MZ value of 150.
The possible structure of the compound C9H10O2 is as shown above.
So this one is the question of the number 2. The unknown compound acts with the molecular formula C6H12O2. So it shows the strong peak and it is the IR spectrum as 1700. And below the table is the 1H NMR spectral data lah. So by using this both data, we need to find out our structure X and also explain why it was this structure.
For the compound X with the molecular formula of C6H12O2, it has a very strong absorption intensity and it has the IR spectrum of around 1700 with number. So this indicates a functional group of carbonyl group.
From the question number 2, we're also using 1H NMR to finding the possible structure. So by given chemical shift given by the question is 1.2, 1.4, 1.9, and also the 3.5 with a different splitting, triplet, doublet, septet, and also the quadrat. And we can find that the assignment for the 1.2 is CH3 coupled with CH2, and 1.4 the assignment is the two set of CH3 coupled with the CH. And for the 1.9, the septet splitting with the ratio is 1. It got a CH couple is CH3 2 set, CH3 2 lah. And for the last shift, which is the 3.5 ppm, it's got a ratio of 2 with the splitting quadrat. Its assignment is CH2 coupled with the CH3. So this one is for the 1H NMR.
So this is the possible structure that we have concluded from the 1H NMR and FTIR spectrum. The compound is 1-methyl ethyl propanoid, which have 6 carbon bonded with O and double bond O. So yeah, this is the possible structure that we have concluded. Thank you.
Assalamualaikum and hi, my name is Muhammad Daniel Birosli, ID number SA21017, and I will continue the presentation with the question 3. In this question, it has provided the IR spectrum and NMR spectrum for the formula C4H8O2. From this question, we have to determine the functional group and the structure of the compound. For the FTIR spectrum, we have choose five absolute peak, which is 2986, 1743, 1437, 1358, and 1086. From these 5 wave number, we have 3 wave number that have the same functional group, which is arcane at wave number 2986, 1437, and 1358. From these 3, we have only one wave number that has CH stretching, which is 2986. The others are CH bending. And next is the 1743. It has a bonding C double bond O stretching that determine it has a functional group of carbonyl. And the last one is a 1086. It has a CO stretching bonding, which has determined ester is the functional group.
For the compound with the molecular formula C4H8O2, it has a chemical shift of 1.2 ppm with the multiplicity of triplet and integral factor of 3. So this assigns that the compound is CH3 coupled with CH2. So next, for the chemical shift of 2.4 ppm with the multiplicity of quartet and integral factor of 2. This means that the structure is CH2 coupled with CH3. And lastly, for the chemical shift of 3.7 ppm with the multiplicity of singlet and integral factor of 3. This a sign that it is CH3 isolated.
The question number 3 also through the FTL test and also the 1H NMR. So this also is possible structure for question number 3 lah, which is the methyl propanoate, which is the propanoate with 3 carbon connected with double bond O and O. Then behind the O is connected to one CH3, which is we call methyl. So the full name of it is called methyl propanoate. So this one will be the possible structure of the compound of the question number 3. So thank you.